complementary events. First of all, complementary events are events that are the opposite from one another. For example, if I let my event A be equal to getting a red ball, for example, event A is getting a red ball. Let's say that we have a container here of balls, and two of those balls are yellow and four balls are red. And event A is getting a red ball. The complement of event A is the opposite of event A. So if event A is getting a red ball, the complement of event A would be not getting a red ball. So for the complement of A, for the complement of A, which we call A bar. Once again, A bar means the complement of A, or the opposite of A. If A is getting a red ball, then the complement of A would be not getting a red ball. So these events are just the opposite of one another. Now, if we look at the example we have here, we only have red and yellow balls in the container. So this means that the complement of A not getting a red ball is the same as getting a yellow ball, because if we don't get a red ball, we would have to get a yellow ball in this case. So sometimes you can take a complementary event and you can express it in terms of some other event, so that we can express the complement of A, not only as not getting a red ball, but we can also express it as getting a yellow ball. Getting a yellow ball is the same thing as the complement of A, which is not getting a red ball, since A is getting a red ball. Now, let's look at the probability of A, and let's look at the probability of the complement of A. First, let's look at the probability of A. And A represents the event here of getting a red ball. Now, to get the probability for A, we look at the possible successes for A getting a red ball. We have a total of 1, 2, 3, 4. 4 possible successes of getting a red ball. So our numerator here for the probability of A would be 4. For the denominator, we write down the total number of possibilities. We write down the successes plus the failures, the possible successes plus the possible failures. Now, the total number of possible events we have here would be 6. This means that the probability of getting a red ball would be equal to 4/6, which of course we reduce to 2/3, and we can change it into a decimal, and we can change it into a percent. So the probability of getting a red ball would be 66.7%. 66.7%. Of course, these figures are rounded off. They're rounded off. Actually, up here we get 0.66 and 2/3. Here we actually get 66 and 2/3%. But a rounded off number will be sufficient for our purposes. Now, suppose we want the probability of not A. The probability of not A. This is another way of saying the complement of A. You can say not A, or you can say the complement of A. The probability of the complement of A, or not getting a red ball, would be equal to the probability of getting a yellow ball. So we can figure the probability of not A indirectly, really. It equals the probability of getting a yellow ball. Because if we don't get a red ball, then we will have to get a yellow ball. So the complement, the rest, what's left over, you can think of the complement as being what's left over in the sample space after you consider the event that you're talking about. So if we just look at A getting a red ball, we have 2 balls left over that are yellow. And we can figure out the probability of getting a yellow ball here. We have 2 possible successes of getting a yellow ball. And we have a total of 6 once again. So that would be 1/3, which is about equal to 0.333, which is about equal to 33.3%. 33.3%. So that would be the probability of not A, or the probability of the complement of A. Now, if we take the probability of A and add it to the probability of not A, for this example, that would give us 2/3 plus 1/3, we get 1. When you add the probability of an event to the probability of the complement of that event, you always get 1, because the complement represents everything that's left over. The probability of the complement is everything that's left over after you consider the probability of the event itself. So now we can have some formulas representing the relationship between the probability of an event and the probability of the complement of that event. For example, a formula we can have is that the probability of A plus the probability of the complement of A equals 1. We could subtract the probability of the complement of A from each side of this equation that we have here. And that would give us the equation, the probability of A equals 1 minus the probability of the complement of A. Another equation. Both equations, of course, are equivalent. Also, if we wanted to, instead of subtracting the probability of the complement of A from each side of the equation, we could have subtracted the probability of A from each side of the equation. In which case, that would give us the probability of the complement of A equals 1 minus the probability of A. The probability of the complement of A equals 1 minus the probability of A. Now, what does this tell us? This tells us that if we know the probability of complementary event simply by subtracting the probability of the event from 1. That's what this formula here tells us. This formula tells us that if we know the probability of the complementary event, we can get the probability of the corresponding event by subtracting the probability of the complementary event from 1. So this will save us some time in figuring out our probabilities.